Okay, so welcome to the second part of sort of review week for the lab exam. All right, basically I'm going to do kind of the same thing we did yesterday. I will take two problems, since we did the first three problems last time. What I'll do is I'll take the final two problems at the end because, well, those are supposed to be the slightly more challenging ones. So I'll show you like what's involved, the slightly more challenging one, and why they may have been considered more challenging, because you might think that, oh, these challenging ones are going to be completely outrageous. I mean, all you need to do to make a problem a bit more challenging is basically have like a couple of steps involved. Like it wouldn't be just as simple as going through and processing, say, some dictionary or something, but maybe once you finally find that information, maybe the dictionary that you're looking for has got a bunch of calculations that need to happen. Like maybe it's got a bunch of test scores and you need to do some average calculation. And we kind of saw one of those with the generated problem the other day. All right, and the same thing, I'll do the same as last time. I'll do two exercises, and we'll take our chances and generate a third one using ChatGPT in an incognito mode. Then we can try working through that one, and I'll hope that we get something that's sort of interesting, just so we can have another example of something to walk through. Okay, and then next week we go back to kind of our, well, we were talking about files, we got some stuff about exception handling, and of course, well, then the good news is that's pretty much it. And the last week we set aside just for final exam review. All right, in any case, here we go. So past exam problems, I've got them open already, and propose that we just pick up where we left off. So I've done the first three out of the regular exam last time, out of the last sort of lab exam last time. So I will do these other two, but of course, as I've already mentioned, unfortunately, previous semesters we didn't include dictionaries, and I know you might be thinking it's just like, yeah, they had it easier. No, not necessarily, because a lot of the stuff that we use dictionaries for is actually to make everything easier, not to make it more complicated. It actually makes it easier. Like, for example, the stuff that I'm doing here would make a lot more sense as a dictionary rather than as a list of lists. And likewise, the stuff that I'm going to do in question number 5, if I had the option, I would never store information as a list of tuples. I would store it as a list of dictionaries. It makes it a whole lot more sense. All right, but anyway, we'll get to that one. We'll get to that one after. Okay. So by including the dictionaries, it makes the data actually more sensible, and it has a result. When your data is more sensible, it's actually easier to work with. Some of the problems that we have to make up because we're trying to avoid dictionaries ends up just making it so that it's conceptually harder to work with. All right, but in any case, here we go. So it says here, suppose we have a list of lists. Okay, yeah, great. So as I say, lists of lists, they don't really occur that frequently. Sometimes you do bump into them, but really having a list of dictionaries is a whole lot better. But as I said, we just don't have it. But this goes on and it says that it contains a bunch of items that need to be purchased. So it's part of like a shopping list type of thing. And the idea was that each inner list represents a different hypermarket. So the way how you would read this is that position 0 might be Lulu, position number 2 might be position number 1 might be family food, position number 3 might be Carrefour or whatever. Okay, and of course, if it was a dictionary, that's exactly what I'd label them as, but we can't. In fact, I can tell you the original version of this actually used to have the name of the hypermarket as the very first thing. And yeah, you think it's complicated now, that's what it started off, and I said, just a little too difficult. Just because you can stick like Lulu in front of that doesn't mean that you should be doing it. But you know what, if I get to the end and I think of it, maybe I'll add it and say, hey, this was the idea that I had. All right, but in any case, write a function named addUniqueValue that will add a new item to a specified list, but only if the item doesn't exist in any of the other lists, not just the ones you're trying to change. Okay, so what exactly does that mean? And you know, this is always going to be the issue. You get a problem like this on a test. You know the coding is usually not big, but it's trying to understand exactly what's going on, and that's why we include a bunch of examples. All right, but here is the way how we would read this. Okay, so I've got 3 lists inside my thing called data, and we're talking about adding a new thing where we're going to specify which list it is. Okay, so in fact right here it says position. So in other words, what I might do is I may say in list number 0, please add, what have we got in here? Pineapple. Okay, and what would happen is the word pineapple would appear in the first list. Okay, or if I say please add pizza to list number 2, I was talking about having, say, the word pizza show up right here before the closing square bracket. However, if somebody tries to add fish to any of the lists, it's not going to be accepted because fish already exists in one of the lists. Okay? I don't care if it exists in the list I'm trying to put it in. I just want to know, does it exist in any of them? Okay, and that's what it says. If it exists in any of the lists, don't do anything. Okay, let's zoom out. Okay, so we keep on going. So the function will accept as a parameter, parameters, the following. So we'll have the list of lists. That's the thing that's going to be modified. The position, an integer representing which inner list to change. Okay, you might be able to pick this up, what that means from the example. And the number must be positive and within the allowed range. Okay, that could be some kind of an error condition. And of course, the string representing the item to insert. Okay, now we go off and we take a look at this. Oh, it says further that the function returns true if the insertion was successful. Otherwise, it returns false if there was some kind of a problem and I couldn't actually put it in. Either the item already existed, or maybe somebody asked me to stick something to list number 25 and it wasn't valid. All right. Oh, and did it say in here? No. It says here that the number must be positive. Okay, so the number -1 is not going to represent the very last item. That's actually a problem. Okay, so we keep that in mind. We go back and we double check everything. Okay, so the examples. Okay, read through the examples and make sure. So we have the original data. So I started at the same data each time, well, almost. And I said, into position number 1, add some broccoli. Okay, well, okay, so what would happen? Well, yeah, you can see that this is list number 1 right here. Sorry, the wrap didn't work so well. And you can see that the word broccoli was added. So congratulations, it's done. And it also printed, but it didn't actually say, oh, here it is. Yeah, it did say in the previous line, true. Yes, it was added. Okay, so what I did was I added it. I printed the result. I got back to true saying it was added. Then I printed the data afterwards. Note that the data is not returned. The data is modified, and you can do that because lists happen to be mutable objects, and sometimes we do this. You did this during the assignment where you borrow or lent books out and accepted books back from people, and you're modifying the parameter. You didn't return a new library, you just modified the library. All right, this one right here, this is an example of somebody trying to add something that's already in the list. Somebody went in and said, okay, let's add fish to this list right here, and of course the issue is fish existed somewhere else, so as a result, no go, we're not going to do it. Okay, all right, and of course that would say false. And another one, the list had 2 things. Somebody tried to add mango to list number 5, but there is no list number 5, so therefore that was also rejected, and absolutely nothing would change. Okay, so here we go. That's the overview about what it is we're trying to do. Now what we will do is we'll go off and try to figure out how we're going to do it. Okay, and the same thing, we'll break it up into a bunch of little pieces because, yeah, there's a lot of things going on here. Like, number 1, you have to know whether or not the item already exists in the list. If it does or doesn't, that's going to impact the rest. You're going to have to find out, is the position number valid or invalid? Because if it's invalid, well, then we have to not do anything. And then finally, we have to figure out how do we add something to it. Okay, so there's a whole bunch of things. Now, the good news is adding something to a list is pretty straightforward. It's a dot append. We know that. Okay, so what makes the problem difficult? You got to check a whole bunch of lists first. Okay, because you're not just checking one list. Yeah. If I said go and try to add fish to list number 2 and reject it because it's already got fish, that's a much easier problem. But what made this problem a little bit more challenging is you have to check all of them. And there's a whole variety of ways about how you can do that. Okay, and what I can do is I'll come up with some ideas about what we could do to make that decision. And we might come up with a couple of different approaches. Okay, so here we go. Here's the basic one. We'll copy this and we will dump it over to here. All right, and we can zoom in a little bit. Okay, so here we go. That's the expected output. All right, well, we know what it's going to be. I don't even care if we see this. All right, so add some unique values, and then we'll try some different things as well. Okay, so here we go. Def add unique value. All right, there are a bunch of things that you need to provide. You need some kind of a list, but I wouldn't use something called a list. I don't know, I'll call it shopping list. If you want to call it data, it's completely fine by me too. All right, the second thing is the list. I'm going to call it the list ID. Okay, so what I'm talking about is this is list 0, this is list 1, this is list 2. If I had a dictionary, I would use those as keys, or better yet, I would use like the name of the hypermarket. All right, not necessary, but I will indent that to make it a little bit easier to read. The final thing is the item that I'm going to insert, and all I'm going to do for right now is return none. And you see, I just want to make sure I've got everything working here. All right, so we got some fish right after fish. Okay, we got a list. I don't see anything weird about this. What have we got here? An unmatched closing parentheses. Yeah, what's up?
Line 14.
Line 14. Oh, this one down here. Okay, here I am looking down. Oh, it's because I forgot to hit this. Okay, sorry. I would have eventually noticed it said line 14. Yeah, thank you. All right, so here we go. Yeah, always read the full error message, not just some of it. I was looking for this one, and I said, wait a minute, no, it's on a separate line. All right, here we go. Again, why we set up as a little test case. If you'd written 20 or 30 lines of code, and now you have even more stuff to track down. All right, so here we go. So at the moment, yeah, we're just printing the data. This is the data after applying the operation, but of course nothing happened, so it's as expected, no change. All right, well, break it into a bunch of steps. I need to know whether or not the item exists in any of the lists. Okay, so let's use that as the first one. So remember, it's not does it exist in the given list ID. I don't want to know if it exists in list 1. I want to know, does it exist in list 0, list 1, or list 2, or list 3, list 4, list 5 if there's more than one. Okay, so how are we going to do it? Well, there's a bunch of different ways how we could solve this problem. One option that is really, really nice, I mean, first of all, everything is going to be completely unique. At least that's supposed to be like this already. But you know, I mean, we've got this little operator called in, and in can be used to figure out whether or not something exists in a list. Or we could take the items and throw it into a set if we want to. Let's start off by dealing with it in a list. Okay, so all that I'm going to do is let's just iterate through all of them, because hey, you got a list of lists. Guess what? Okay, for X in shopping list, print X. Okay, let's see what we've got. Okay, as I say, this is the way how I work, is just let's see what we've got. All right, so each of those things, of course, is, well, probably a shopping list for a particular market. So instead of calling it X, I'm going to call it, I don't know, market or destination, whatever you want. Maybe market items. That way it makes it very, very clear what I've got. So we'll print out market items. All right, so what this is, this represents the market items that I want to pick up in a particular location. All right, I'm not interested in knowing whether or what the market items are. I want to know whether or not they contain what was ever passed in an item. Okay, so we got this nice little function, or sorry, actually it's an operator, not a function. We've got this nice little operator called in, and what this will tell me is whether or not a particular item appears in the market items. Oh, okay, so here's what I'm going to do. I'm going to print both the market items, so here we go, market items, and I'm going to print whether or not the item that I'm searching for is in the market items. So remember what we're searching for. We're searching for broccoli. Hey, look at that. Broccoli doesn't appear in any of the items. Of course, that makes a lot of sense. Since we're here, let's do this. Not that. Okay, tomato. Okay. All right, so what's going to happen this time? Well, what I'm hoping is going to happen is that the second list says that, yeah, it was there. Oh, yeah, good. So it existed somewhere. Well, let's use that to our complete advantage. You see, if I ever find a true, okay, so if I ever find the case that item in market items, do I need to do anything else? And the answer is no. I'm finished. I don't need to look at anything else. I'm done. If I'm going through these lists and I ever find that tomato happens to be in one of these lists, I'm just going to stop. And of course, I'm going to return false. Now, see, if I run this, now you have to sort of interpret the output. Remember what happens is This was the very first hypermarket list that I looked at, and of course it didn't contain tomatoes, and as a result it carried on, did the very next one, but the very next one showed up as, oh, hang on, there's tomatoes in this list, so therefore what happened is I immediately returned false, and this happens to be the output. So maybe what I will do is, we'll just print the information here. Okay, that's the stuff afterwards. This one right here, this is the result from the function. So I'm going to label this as a function return. Okay, that way we know exactly what it is. So it's a function returned false. Okay, there we go. There's our first bit. It wasn't that difficult. Okay, but here we go. What do we do at this point? Okay, well, if I make it to this point right here, then what I'm going to do is I'm going to keep going. You notice that I'm not going right now. I basically stopped and I said, yeah, false. All right, let's go back to what we had before. Broccoli. I don't care how it's spelled because we're not going to try to add. We don't even want to add it. All right, but in any case, here we go, because nobody wants broccoli, right? Maybe I should pick something else that we would like. But in any case, it says keep going. In other words, I made it through the first check. Oh, hey, what am I checking for right here? There we go. Yeah, that's what we use comments for. I mean, you're not required to do this, but that's what we use comments for. All right, in fact, probably what I would do is at this point, I might say, here we go, if we can, hello, not there, not there, there we go. You might say, okay, the item didn't exist. Okay, so I'll leave this up and obviously keep going. All right, well, at this point, we now have to check the next condition. Okay, so you notice we haven't even worked on the general case problem yet, which is adding something at the end of the list. We first of all just want to go through all the lists and make sure that the item didn't exist. Okay, all right, so keep going. All right, so keep going. So obviously the item doesn't exist. Okay, so I'll just say doesn't exist. We can clean this up afterwards. Doesn't exist. All right, next one up. Well, maybe what we want to do is we want to check to make sure that the list ID is within the allowed range. Okay, so let's try working this one out. You see, if the list ID is less than 0, I've got myself a problem. Okay, and because we've already said in the question, the list ID has to be a positive number. So, sorry, it can't be less than 0. If it ever is less than 0, then what I'm going to do is I'm going to return false. Okay, and we're going to check that one right now. So somebody gets smart and says, okay, I'm going to ask for position number -1. Yeah, we're going to kick out this way. And you know, just for fun, what I'm going to do is I'm going to say invalid list ID. And again, we don't use that as our final solution, but it's good to keep track of what's going on. Okay, so that's an invalid list ID. All right, well, how about if somebody asked for list position number 10? Okay, well, right now, it keeps going. Okay, yeah, we have to stop this one as well. Because what's the highest list ID that I could have in my particular case? Yeah, 2. Good. I can see. I either see somebody saying peace or maybe we actually mean 2. Okay. Either way, that's good. Yeah, so it's 2 people. Or sorry, the number is 2 because there's 3 lists. So obviously what I could do is I could do something like this. I could say, okay, list ID is equal to, or sorry, less than this, or list ID is bigger than 2. Then obviously I would stop. Okay, there you go. So invalid list ID. Of course, this is going to fail miserably because I can't hard code the value because we don't know how many lists are coming. Maybe there's 1, maybe there's 2, maybe there's 5,000. We don't know. So unfortunately, what we need to do next is we need to figure out how many lists there are. So how do we figure out how many lists there are? Let me put another print statement in here so we know if we've got the correct thing, and then we can try a couple. All right, so how do you figure out how many lists there are? Well, remember that data is the thing called shopping list. The length of the shopping list, because it's a list of lists, that's going to tell you how many lists there are. And that is going to be exactly 3. Okay, so somehow related to this. So there are 3 lists, and here, you know what? If I add a couple more lists, how many lists do I have now? And now I have 5. Okay, good. So now it says 5. So I know how many lists there are. But of course, what I have to do is I have to be careful because I want to make sure that I don't go beyond. Okay, so maybe what I will do is I will call this num lists, which is going to be length of shopping list. Okay, and I just want to make sure that list ID is, if it's bigger than or equal to the num of lists, then I have myself a problem. Okay, and that's going to be the way we're going to get this out. Do I need the variable called num list? No. You could just use bigger or equal to length of shopping list. That's fine. I like to spell it out here just because I'm explaining things. All right, so what we will do is if somebody asks for list ID 10, yeah, that's going to say invalid list. There's my way out on this one. But if somebody asks about list ID number 3, is that currently valid on my data? And the answer is yes. So I shouldn't see that message. You go away. I shouldn't see that message this time. Let's press that button instead. Okay, here we go. So notice that I made it to the end where I'm returning none, okay, because I made it through the invalid list check. Okay, good. This is what we're looking for. Okay. Oh, and if I have these empty lists, is that a problem while I'm checking for things? No, because if you're looking for broccoli, it's definitely not in an empty list. All right, perfect. So we got through there's a couple of extra ones. Let's clean this up. Do I have a problem right now? Yes, I do. This one should trigger the invalid list ID, which it does. Okay, and sometimes what I will do when I'm debugging code like this, I'll stick a bunch of stars just so it really stands out. Remember, all of these print statements, this is just temporary. Just temporary. All right, so finally we've decided. So at this point right here, okay, we know that the shopping lists or the list ID is okay. And again, I could leave a comment in here and say, okay, well at this point here, I know that the list is okay. So at this point, the list ID is okay. All right. I've made it through the gauntlet. I've checked all the error conditions. And by the way, this is a very typical way how you would write a big, long, complicated function. You put all of your special cases at the beginning, and you find ways that if it's going to fail this way, then stop. If it's going to fail this way, stop. And you keep calling return because remember, as soon as you find return, that's it. We don't carry on. Okay, so that's why I put these. You can't kind of catch the problems at the end because at that point, it'll probably be too late. And that's a very typical pattern that we end up using. All right, and that's why the other cases, when suddenly you start handling special cases, it almost always goes at the beginning. Okay, doesn't mean that it always works, but most of the time you want to process these special cases at the beginning. And those were special cases, those were the oddball cases. At this point here, it's pretty straightforward. I've got myself a list. Okay, the list ID is valid, and I know that there's no duplicates. So the only thing left is I go to the shopping list, I go to the thing called list ID, and remember that that is a list, and all I need to do is just append the item at the end. Okay, so if I try something like this, if I try adding broccoli, nothing happens because, well, it's an invalid list ID. If I tried to add to position 1 like I originally had, you'll now unfortunately discover that broccoli has been added to your shopping cart. Okay, and at the same time, if I go and I try to add fish to that list, I also got back a return false, but you'll notice the fish didn't get added because it was in all of the other lists. Okay, or sorry, it was in one of the other lists. All right, so at this point here, really the only thing left to do is, yeah, you do a little bit of a cleanup. Okay, and yeah, you wouldn't want this because the whole function is supposed to return, and there you go, and there's finally, I'm still printing the function return, and I am printing out this, so I know that things are operational. All right, so what made this a little bit harder? All right, what made it a little bit harder is before we ended up doing any work, notice that I had to do this. I had to iterate the entire list. I didn't do anything, but I had to iterate the list to find out, is one of the conditions invalid? That's what made it a little bit more challenging. It was a 2-step problem. Okay, I don't really consider this to be much of a step. Okay, but I mean, I suppose it makes it a third step. That one's not challenging, but we actually had to go through each of the lists first and make sure that things weren't there. So that's what added the extra challenge for this one. Okay, at this point, add a doc string, copy and paste something, or write something up, and yeah, you submit it and you move on to the next one. All right, but that's what made it a little bit more challenging. Okay, it wasn't a really big complicated data structure, although big complicated data structures add to the cognitive load as you're working through it, but the fact that we had to do a couple of things to get there. Okay, so that's what made it a little bit more difficult. And that's why we called it this level of a problem, rather than one of the very straightforward ones, where a straightforward one, you might just check to make sure that it was okay, and then maybe add it. And maybe add it only if it didn't already exist. Okay, that's how I can move this one from a question 4 to a question 3, or whatever numbers I've got. All right, so there we go, bang, done. Let's pull up the next one. Okay, so back from the side, and what have we got in here? All right, the following data structure is used to track which courses that a student are currently enrolled in. Okay, so many. Tuples in the list represent an individual student. Again, I don't like the question. Basically, we had to kind of work around it because we didn't have dictionaries. And it's really not a natural fit for storing a bunch of information like this in tuples. This does happen, by the way, sometimes. If you were to pull a bunch of data from a database, the database may give you back a list of tuples. I'm constantly dealing with tuples out of MySQL databases. I don't like them because I find that tuples are just a little bit more complex to work with, because you have to keep using ID numbers, and you say, yeah, but they're just numbers. Yeah, it's okay when you have 4 things. Some of the database tables I work with come back with 50 or 60 columns. And sometimes I'm literally saying, okay, I'm looking for column number 57. And literally, I'm counting the things up. It would be so much easier if it was a dictionary. All right, and usually I get it wrong, and then you have to pick, oh, it's not 57, it's 58 because I miscounted something. All right, but in any case, it is what we've got. So tuples in the list represent an individual student. Each tuple is comprised of the name of a student as a string, the name of the program as a string, and a list of courses that the student currently enrolled in. And each course, of course, is a string. All right, so what makes this one a little bit more challenging is it's a list of tuples, and inside the tuples, one of the elements happens to be a list. Okay, yeah, I mean, this adds to the complexity. So yeah, this is the one that we made worth 5 marks, and kind of like I was expecting only the top students to be able to get this. That's pretty much what ends up happening. All right, so we were asked to write a function called drop course that takes the following items as a parameter. So it's going to be the registration data. It's always the first thing that goes in. The name of the student, the name of the program, okay, so a couple of things, and the course to be removed. So in other words, it's like dropping people. Okay, sorry, it's dropping a course. Why did I pass in the name of the student and the name of the program? Well, it was in case there happened to be 2 students with the same name in 2 different programs. Yeah, normally you would end up passing in like a student ID, but hey, in this case, you need to have both of these to match. So if somebody said, yeah, Fatma would like to drop infs1201, who's in AI, you would search through the entire thing and go, whoa, hang on, there's no Fatma in AI. Okay, and you'd say, yeah, I'm not going to do this. Okay, all right, so the function doesn't return any value. Okay, but it could return a true and false just like before, but it does modify the registration data so that the requested course is removed from the student's registration. Okay, so pretty straightforward. If I did say to remove infs1101 from Fatma, then we would see everybody else unchanged, and Fatma would have exactly 2 courses, not 3. But there was an extra twist in here. Again, this was to push it up into the final thing. And it said, if after removing the course, the student has no more courses in the record, then the entire student is removed from the registration data. Yeah, you drop all your courses, maybe you get kicked out of the program. I don't know, that was the idea. All right, and of course, if you try to remove a non-existent student or a non-existent course, the function just doesn't do anything, and it kind of silently closes its eyes and it says, okay, whatever. It doesn't make any modifications. Okay, a real system would probably provide an error message, but this isn't a real system. This is like at the last few minutes of a lab exam. Sometimes we break reality to make the lab exam a little bit easier. All right, so we've got a whole bunch of a few different examples, and I would say probably what we want to do is to start with the basic case, okay, and I'm going to take this information right here, okay, and we'll paste it in, and all that this is just the output. Okay, so let's see, we'll paste it over to here, run, okay. unexpected. Okay, so sometimes when you copy and paste from the other side, it doesn't work. Okay, so here we go. Drop student is not defined. That's completely fine. Again, normally I would indent these things. I'm just going to leave them here so we can see it all. Okay, but it would be nicer to indent. And of course, we'll have a function called drop student. Okay, and all that I'm going to do is I'm just going to return something for right now. Oh, I don't actually need to return anything at all, do I? Because the function doesn't actually return anything. So all that I'm going to do here at the end is I'm just going to say literally blah. Okay, doesn't work yet because I need 4 parameters to be passed in. I need the actual course data, so let's call it registration data. Again, if you just want to call it data, it's fine. We would need the student name. Okay, I'll just use student. I would need the program code or the program name, and I would need the course. All right, here we go. Excellent. So my function does absolutely nothing except it prints blah, and then we print all of the data afterwards. Okay, excellent. So now let's go through and see if we can figure out how to get rid of a course from a student. All right, well, in order to get rid of a course from a student, you're going to have to isolate the student themselves. So if I'm looking for Fatma in cyber, I have to get down and I have to get the exact record for that student. Okay, so let's see if we can figure out how to do that. You know how this is going to play out. It's going to be almost exactly the same as what I've done before. I'm just going to start by printing everything. For X in registration data, okay, here we go. I'm going to print X. Bang, there we go. So the word blah, of course, that's afterwards. Let me do a print, dash, dash, sorry, a bunch of dashes. Okay, so the stuff after is the return. I don't care about that, but I'm just please focus on the stuff before the line. All right, so right now that's printing all of the information. Well, it's a list. It's a list of tuples. That's good. I've got a bunch of tuples. What I need to do next, of course, I need to come up with a variable called, instead of X, what do we call it? All right, well, I guess the question is, what would you call each of these? Be careful here. What would you call that? Immediately what comes to mind is, well, that's a student. But the problem is I already have a variable called student. Now, I suppose what you could do is you could have something up here called student name, and then we could have a student. And of course, well, this is the student name. Oh, I've already got a student name. This right here, this is the, I've already got a program. Okay, sometimes the verbs, sometimes the words and the variables end up just conflicting with everything. And of course, the final thing that shows up, that's okay because that's the currently registered programs or the currently registered courses. Current courses, hey, that makes a lot of sense. All right, now notice that each of these has exactly 3 items. Well, hopefully you remember that there's a kind of a cool little trick when you're iterating through lists of tuples. You can pass out A, B, and C, and I can print A, B, and C. Okay, and that gets them out of the tuples already, so I don't need to have square brackets because who wants to say square brackets 1, square brackets 2? Okay, all right, easy one, C. C is the current courses. There we go, current courses. I like that name better. All right, unfortunately, now what I need is I need to come up with a name for A. Okay, well, that one's not bad. That's the student name. Now, student, of course, is also a name up here. Oh, okay. So here's quite often what I will do. Let's call this the student key. We just went through searching and sorting. Remember that the key, when we're dealing with searching, that's the thing we're searching for. Okay. So I'm going to call it student key. And if you come up with a different name, it's completely fine. And maybe if I think about it a bit more, it's going to be easier. Oh, and guess what? I'm going to do the same thing for the program. I'm going to call it program key. And I'm going to, instead of calling this A, I'm going to call it student name. And I'm going to call this program, student name, and I'm going to call this program. Notice that all that I'm doing is I'm just renaming variables. I haven't even done anything else yet. I'm still nowhere closer on the problem. But at least I've got some nice variable names because a good set of variable names will make the code much easier to write. Somebody once gave the comment about if you just pick the right variable names, the code writes itself. Okay, well, unfortunately, it doesn't quite do this, but it does get you an awful lot closer. All right, and the final, we had one extra item over here, and it was called the course. And just so that we know what it is, since we're using the key for everything else, let's also call this a key. I really wouldn't use the term key here, but okay, the parameters, this is what we're searching for. Okay, that's reasonable. All right, right at the moment, I am printing absolutely everything. Okay, is that good? And you might say, no, I don't want to print everything. I'm just interested in one student. Okay, well, if I was only interested in one student, maybe what I could do is I could leave an if statement and say, okay, if the student name is equal to the student key, then I'm going to print it. Okay, now take a look at this. I've got it down to the one person that I'm interested in. But is it enough? In this particular example, it is enough, but remember what I said. Maybe your data set looks like this. So we have a Fatma who is in cyber, and we have one who's in AI. And the problem is that if I run this program right now, both of those are going to match. Okay. When you hit the course on database, because I know everybody here will take the database course, you will learn about this. They're called primary keys, but unfortunately the name doesn't make a very good primary key because I can't narrow it down to a single person. But by including maybe the program, I could. Okay, so in other words, I don't just look to find out whether or not the student name matches, but maybe I also need to find out whether or not the program happens to match the program key. Okay, and the result is now I'm down to one person. Now, okay, yeah. Right here. Remember, when you extract something from a list of tuples, if you provide a tuple, it will automatically fill that out with the second item. Okay, it's a really clever thing. It avoids me from having to talk about exapposition 1, right? Because although this works, it's a lot nastier to say if exapposition 0 is equal to student key and exapposition 1 is equal to program key. It's easier to read this way. Yeah, and if you want to use the indexes, it's completely fine. It's just, I thought it makes this a little bit easier. Okay, now, this gets me down to one person. Unfortunately, somebody's going to say, yeah, but what if there's two Fatmas also who want to take cyber? Okay, in this institution that we have here, then the 1201 lab exam institution, the University of 1201 lab, that's a restriction. If somebody else is in a program with the same name as you, you're not allowed to join. It's an artificial restriction, just sometimes to make the program or make our problems a little bit more challenging or a little bit easier. Yeah, it would be easier with a student ID. Okay, but anyway, it's not about making it easier, it's about processing the data. But okay, so we've narrowed it down to one particular student. Good, we can print it. If you can print it, you can do things with it. Well, hopefully. All right, so here's the first thing I'm gonna do. How do you get rid of something because right now, I've got a current course. Okay, now, let me just do something. Current courses dot append blah 1000. What would this do? Would this actually result in Fatma being added to this course? And the answer is yes. Because what you're able to do is, because this came in as a parameter and it's a mutable object, and so is the list inside, you can modify these things inside. So whatever you're doing to the list, you're actually doing to the original outside parameter. So you can see I can add something. Okay, this is just like what we did in the library. Borrow a book, it gets added to the current people. You return a book, it gets removed. Oh, okay. So I'm not interested in appending something. How do you get rid of something that's already there? Pop? Maybe. Okay, so that's an operation. Okay, we're going to hang on to this word. Okay, we'll talk about this. What's the other word? Yeah, remove. Remove is the one I'm actually interested in. Okay, so what I'm going to do is I'm going to try removing DAX 2101. Yeah, I know that's not the problem, but just let me remove it for right now. Because if you can remove one hard-coded value, then it's pretty simple to remove the others. And take a look at this. You know the data before Fatma in Cyber used to be in DAX 2101, but you see after this, now they're not. Okay, so in that case, instead of removing this one, why don't we just remove, well, I called it course key. There we go. And now it's gotten rid of infs 1101. Okay, hey, not bad. Now, here's the problem with pop. Okay, pop is also used to remove something. Oh, I've got other problems yet still. Pop is used to remove something, but what it takes as its parameter is not the value you're trying to get rid of. It takes the position that you're trying to get rid of. So in other words, you can say pop 0, and that would get rid of the first item. Pop 1 would get rid of the second item. Pop 2 would get rid of the next item, and so on. Pop -1 would get rid of the last item. But the issue is I don't know where the course is located. I just want it gone. Okay, so the remove is much easier in this case. However, we also have a bit of an issue. What happens if we wanted to take and remove infs 1201 from Fatma, who's in the Cyber? Now, here's a bit of a problem is Fatma actually taking infs 1201? And the answer is no. What's going to happen when you run this program? Oh, you have to know this for the final exam, by the way. This is a tracing question. This isn't a tracing question to find out, but these are the types of things that could be asked. What would be the result if I ran this? Does it ignore it? Does it crash with some kind of an error? Does it add it because it wasn't there? It doesn't work. Okay, well, what exactly does that mean it doesn't work? Does it ignore it, or does it actually crash the entire program? There's your answer. Okay, there's your answer. This one, just like in a set, if you try to remove an element from the set that isn't there, it shows up as, well, basically, well, in this case it says a value error. If it had been a set, it would have shown up as a key error. Okay, yeah, so this is an issue. You can't call remove unless the item is there. Okay, so in that case, what you need to do, okay, so no, it's not a pop. What you need to do before you remove it, you have to ask the question, if course key in current courses, then you can remove it. Okay, now it continues on. So yeah, it's dropped, but it doesn't crash at least. A better program might return back some kind of an error message saying, oh, hey, the student wasn't there, but this is the result after removing infs 1201. Okay, yeah, it was completely ignored. That's probably the operation we want. Unfortunately, in Python, the remove operation actually gets rid of this. All right, so there we go. There's the first problem. So I can now deal with anything. Oh, what about how about the new Cybery program? What should happen in this case? Well, nothing should happen because there's probably no Fatma in the Cybery program, and yeah, this ends up looking exactly the same. It happens to look after, it's looked after by this if statement, so we don't have to worry about that. This one's being handled. Now, we need to move on to something that's much, much nastier, and that is going to be Mohammed in the AI program, and I would like to remove the infs 1201. Okay, so if I run this one as a test case, I'm going to ask, was the course dropped correctly? And the answer is yes, it was, but you have an issue. Okay, and the issue happens to be that now I've got an empty list. And if you remember, there was one extra condition on here which said if a student ends up dropping all the courses, that means that that student should be completely removed. Okay, this is probably one of the trickiest things, is how do you get rid of this? All right, now to get rid of something, you see, you can't use a remove directly, right? Because I'm talking about getting rid of that entire Mohammed AI record. Okay, you see, after I remove it, it's not an issue because I can do a check like this. I can say if current courses, if the length of the current courses, this is actually going to burn more time than I expected today, then here's what I'm going to do is I'm going to just leave a comment in here for right now. Oh, last course removed. Okay, so you can see that that's being triggered. So whatever I have to do inside that if statement. That is a problem. Now, this is really, really tricky at this point. And again, this is why I made this like one of the high value points, or one of the high value questions not worth so many points. And did people get it? And the answer is yeah. There's a couple of different ways how you can get it. In fact, there's many different ways about how you could do this. But as I say, I had about maybe 5 or 6 people got this. Some people got close. Some people really got close, and they left this one out. And I believe that I may have given like the 3 out of 5 for that one because at least they had this much. All right, but in any case, print the last course, or sorry, we know that we've down to the last course. How do we remove something? All right, how do you get something out of a list? You have 2 options: remove when you have the name, and the other is pop. Pop. Okay, well timed. All right, so we have a pop operation. The pop operation requires I know the index. But if I knew the index, it's pretty easy. Just to let you know, like for example, if I went to the original registration data and I said pop2, that would get rid of my student. But the thing is how do I know which number? Okay, I mean, obviously I could see this, but how in the code do I figure out which number I happen to be sitting in? Okay. This is the way how I would do it. I'd have an index that starts at 0. Every time I go through, okay, at the end of my if statement, right here, I would probably say index goes up by 1. And I'm just going to put a comma here, and I'm going to say index, and I'm not going to get rid of it yet. You see what I've got? Is that gave me exactly the place where it was. So what I did was I set up an index counter, and basically I counted alongside. Okay, yeah, it wasn't just, okay, I got to loop and do this. If you ask ChatGPT to do this, it's going to give you a whole bunch of stuff in here, and you're going to bump into something called an enumeration, and it's going to say for whatever, in enumerate. Yeah, I don't cover that because we don't need that type of stuff here very often. But we can solve it without the enumerate because all we need to do is keep track of where we are. So in other words, the only thing that I really need to do at this point, and you have to be very cautious about this because a lot of systems have this type of an issue. So here we go. I would simply say that the registration data pop index, okay, and that's it. And at this point right here, I would then get myself out of this function. All right, and the reason why I'd get myself out of the function is because most systems, and I think Python is similar, if you're iterating through the list and you remove something, you should probably stop iterating. Usually you can't continue to iterate. Python has got some rules about what you can and can't do, but most systems, once you delete something, you have to stop the iteration. So in other words, if you had to get rid of all of them, it's actually a pretty tricky thing. Okay. All right, so there we go. That's probably what I'd end up doing, and now it's gone. Now clean up the print statements, and we're pretty good. Add over a doc string. All right, so complicated? Yeah. What makes this complicated? What made it complicated is the removal itself of the course wasn't so difficult, but the removal of that registration data, yeah, that is actually pretty tricky because it was suddenly like I have to keep track of where I am because I have to use a pop because that's the only thing that I've got. Now, some students actually went back and they created a brand new tuple with the name of the user and the program and the empty list. And you could use a remove. I really don't think it's a good idea, but I also had to accept that. Okay, but that's how I would solve this one. Yeah, a little more complicated. Okay, that's what kind of the complicated things look like. All right, so next one up then. Okay, well, I've got a few more minutes. Well, actually, I don't have a few more minutes. I have a whole pile of work waiting for me, but hey, why not? Over to ChatGPT. Okay, here we go. ChatGPT, and let's hit the same prompt, and I'll see whether or not I get scared of whatever I get asked. Okay, all right. So we need something for another dictionary. So let's see what we get. So you are an expert Python instructor. Okay, blah blah blah. Let's put this in, and here we go, and paste. All right, let's see what it comes up with. All right. The one thing, by the way, you'll always find. If you've been using ChatGPT to generate problems, the first thing you realize is that it is not very creative. It starts off, the first time you see it, you go, wow, this is really cool. It comes up with all kinds of things, but it almost always comes up with stuff about courses, warehouse inventory, that's pretty common, student activities, Regional temperature processor, so some weather type stuff. Yeah, that always happens. Movie analytics. Yeah, these happen. These happen all the time. Why is it? Well, you have to understand where ChatGPT gets its information from. It gets it from various places on the internet. It goes out and its sources and it says, okay, so I've learned that these types of questions might involve student things, and that's what all the examples are like. If you immediately push something over to another domain, it's actually really good at it, but it just happens to be that if you don't push it, it keeps coming up with the same examples over and over again, because these are the typical examples that show up in textbooks. And unfortunately, when it shows up on a lab exam, I tend not to follow the same as the textbooks. All right, let's take a look and see what we've got. I don't know if this is really that great today, but okay, we'll give it a shot. Okay, this is not as complicated as what I was hoping. Okay, but hey, we've got something. It has a dictionary. Okay, that's pretty decent. I suppose what we could do is we could go back and say, we could maybe make the problem a little bit more interesting. All right, because what we've got here is we've got a dictionary where we've got a bunch of courses, and then we've got a list of how the students have done within the courses. Okay, well, fine, we'll do this. If I was looking for another one, I might say, please repeat question number 1, but use only dictionaries. And now you've got a list of dictionaries or something. I don't know exactly what we've got in here. Okay, so you might go back and say, okay, just make this a little harder or maybe add something extra. All right, so what is it that we're supposed to do? We're supposed to summarize the enrollments where the data is a dictionary, whose keys are course codes, and whose values are lists of tuples in the form of student name and grade. Okay, your function must traverse the dictionary and count how many students are enrolled in each course. Okay, and compute the overall grade for each course, and then return a dictionary mapping each course to a tuple containing the count and the average. Ooh, okay, so the response is going to be a dictionary with the course code followed by the number of students in the course followed by the average. It feels like I've just done this not that long ago. It's because the examples keep coming back over and over again. All right, but in case, yeah, we'll give it a shot and see how this goes. Okay, and then I can provide a comment about whether or not I think it's a difficult problem or not. Honestly, I don't think it's a really difficult problem. Okay, let me grab, it says that we're going to have a function called summarize enrollments for data, and obviously I would give you a little bit more. I'd give you something like this and say, okay, here you go. We're going to summarize the enrollments, and I am going to, what am I supposed to do? I'm supposed to print this because it's going to return a dictionary. Okay, here we go, and let's stick in a function. Summarize enrollments, and okay, I'll keep it as data this time. All right, this is going to return something. Start this way. All right, let's double check and make sure you don't have anything else. All right, so that's the only thing it takes. Now, again, traverses the dictionary. I would never use those verbs. Okay, by not using the verbs, now it's up to you to figure out how you're going to deal with this thing. And yeah, of course, you're going to iterate through the dictionary. All right, so yeah, we have to iterate through the dictionary. Well, let's just iterate through and see what we've got, come up with some names, and maybe it'll make a little more sense as we go. All right, so what we're supposed to do is we're supposed to figure out the number of students in each course and the course average. Okay, that's two separate things. Okay, and I'm going to solve it as two separate things. Not because this is the way I would solve it, but I'm going to solve it as two separate things because this is the way how hopefully you remember from INFS 1101, functional decomposition, problem decomposition. Solve one piece at a time. Once you have both things put together, then somehow or another figure out how to put these together. But it would at least start as two separate things, and maybe I've got to combine it, maybe not. Okay, so I've got some ideas about how I'm going to go, but yeah, you know how this is going to be. For X and data, print X, what have I got? Okay, those are, those are just the names of the courses, but I'm missing all of the interesting information in my course registration data. Okay, but what would I do instead? If I wanted both the names of the courses and the information about the scores? Yeah, you'd probably use the items, right? All right, there we go. We got all the information. Okay, but of course it's maybe a little bit weird. So let's give it a couple of names. The first thing is the key. That's the course code. And what would you call the second thing? Student results. And if you want to call it students, that's fine too. Course code and student results. Okay, so we've got that broken out. Just to keep it as simple as possible, you saw me do this before. What's going to happen? It's going to give me one that's going to stop. Yeah, because if I can do it for one, I can do it for all. And then we can just remove the break afterwards. It's not going to be here all the time. This is like some temporary debugging ideas. All right, so there we go. There's the information, but it doesn't contain the stuff that I'm looking for yet. But some of the stuff is going to be very easy. Like for example, how many courses are there for how many students are there for CS101? 3. Now, take a look at what it is. It's a list. How do you figure out how many things are in a list? There we go. Length of student results. That's the student count. Here, let me add this. Student count. There we go, 3. Excellent. If you want to check this to make sure it's actually working for all cases, okay, remove the break for a second. Yeah, so 3, then 2. Yeah, it works fine. There's no restriction. I think the exercise we did yesterday, we had to ignore the things that had negative values. This one didn't have. So this is even easier than yesterday. Wow, I was incredibly lucky. But in any case, that's the student count. All right, well, the second thing I need to do is I need to calculate the average grade for each course. Oh, all right, well, to calculate the average grade, how do we do this? Well, the way how I'd calculate the average grade is I need to go through and I need to add this number, and this number, and of course divide by the number of students. Now, there's a couple of different ways how I can add these things up. The easiest way, and I've talked about it before, if you can take all of these numbers and stuff it into a list, then you got access to your favorite function called sum. Yeah, okay, well, let's do that. Let's turn these things and put them into sum. Let me go back and put a break in here because I don't want to be confused by seeing multiple students. One student is enough for right now. All right, and here's what I'm going to do. I'm just going to go for x in, student results and print x just to see what I've got. Yeah, there we go. So now we've got each of those items is, it's a name and a grade. Name and a grade. Okay, print name and grade. Just to make sure I still got it. There we go. Now it's no longer a tuple. It's easier to work with if it's not a tuple, all right? Because you can use comparison operators, you can use plus and all of these types of things. And of course, what am I going to do? Well, I would like to have a list of grades. All right, well, it's a list of grades for each student. So let's have an array here called this. Oh, sorry, not an array, a list. Sorry, sometimes I get mixed up because of my other course. All right. Arrays and lists, by the way, are the same thing. It's just in Python, they're always called lists. All right, so what I'm going to do is I'm going to have a bunch of grades, and of course, instead of printing them, well, I'm going to build up a list. And you can see now why I've been through that a whole pile of times where you start off something with an empty list and you keep appending. So you append the grades. All right, so let's print grades. Let's not print student results anymore, but we'll print the grades. Hey, you see, I've got this. Oh, in fact, I don't even need the student count anymore because I know the student count. Okay, how do I know the student count? Well, how many grades are there? 3. So how many students are there? 3. Oh, good. So I don't need that as a separate variable. That's just going to be the length of grades. All right, and of course, how do I calculate the average? Well, it's the sum of the grades divided by the length of the grades, and I'm finished. Okay, so let's do that. Let's have the average. The average. Okay, that's going to be the sum of the grades divided by the length of the grades. Okay, and all right, since we have here, we'll have grade count. I'll put it back. That, of course, is just the length of the grades. Let's print these all out and make sure that we see something. So this is the average, and this is the grade count. All right, do we have the information? Okay, 85%. 88, 75, 92. That sounds to me like 85. Okay, you check the sample and you'll be okay. And it's 3. All right. If I remove the break for a second, does it make sense for the next course? Okay, 81 and 89, yeah, that's definitely 85, and there are 2. All right, we got all the information. The only thing left to do is to put it into a dictionary that I can return. Okay, how do you build up a dictionary? Build a dictionary. There we go. There's a dictionary. It has absolutely nothing in it. And what's it supposed to be? Well, the dictionary key is the course code. And what are we supposed to have in it? Well, if you remember over here, what I'm supposed to have is a tuple. I'm supposed to have the number of courses and then the average. So number of courses comes first. That's called the grade, or sorry, number of students. It's called the grade count, and the average comes second. And close, and the only thing left to do is just to return result. Okay, so would I call that a question number 4 or 5? No, that's not a question number 4 or 5. This is like question 2, maybe 3, because there's not a lot of stuff that I have to do, except that I had to iterate through and extract the grade to get it into a list. I can make this considerably easier if I change the data to look like this. Okay, I won't repeat this one, but imagine if I were to replace it with this information. Okay, and this one right here, and from here, and here, and here. Okay, if that was the dictionary, that becomes really quite simple at this point. Because at this point, you just need to pick up the values. That's the second thing, if that's the value out of this. And now you can directly deal with this. So that's like a question number 1 type difficulty, maybe 2. Okay, this is the way how we grade the questions. When you look at it, you say, okay, where does it fit? Because we always don't just sort of make them up and say, yeah, good luck. We actually do look at them and say, okay, is this the type of thing we're looking for? Does this make this easy? Does this make this hard? Okay, so yeah, that's a bit easier. It's a bit of an easier one. The one that was generated was unfortunately a little bit easier, and that's the unfortunate thing is ChatGPT, when you're looking for simple things, it'll give you difficult things. If you're looking for difficult things, it'll probably give you simple things. All right, go back to it and ask for something harder. Okay, so what could we do? Well, just to give an idea, give me something like question 1, but make it much more difficult. Okay, just to see what we've got. A much more difficult version, okay. Multiple nested structures, multi-step aggregation, cross-referencing, and returning a deeply structured result. Sounds scary. Okay, student, for each instructor, okay, this is pretty big. Now, I don't know what it is they're going to ask for, but take a look at this problem. I've got both assistants and students, and I've got students with grades inside. Yeah, this is definitely going up. Does that? Oh, and what are we looking for? We're looking for average grades, pass-fail counts, overall averages, assistants, and I suppose somewhere in here there's probably some instructors as well. Would I ask anything like this? No. This would be pretty big. How would you approach the problem? That's kind of important though, because if you can handle something like this, you can handle anything that I'm going to throw at you because it's going to be smaller. How would you deal with it? Okay, well, to begin with, I would completely ignore all the stuff about the faculty. Okay, and just forget the instructors. Deal with that later. You start off by looking just at the courses. Can you get the student averages? Ooh, okay, so how would you deal with this? Well, you'd go through this dictionary, and of course, well, inside the students are showing up inside a list, and yeah, I've got a bunch of names in here. To get the average for Alice, that's pretty simple, but you have to work your way down to it. Okay, now, that on its own, that would be more than enough for a lab exam question. Okay, not worrying about trying to toss in other things, but literally what I would do is I would start off and you say, okay, I just start off and I forget everything else and I just look at student averages, and you solve that problem. You don't solve anything else, you solve just that problem. And then you worry about adding a pass count. And once you get that, then you worry about adding a fail count, because that'll be easy. Then you worry about trying to figure out the overall average, which is probably really difficult. And, well, the assistance, I think, was just directly there, so there's nothing difficult about that one, okay? That's the way how you decompose these really big problems. But you can see without dictionaries, I can't ask stuff like this, and you never get a chance to practice your problem decomposition, because if the problem is really, really small, it's harder to decompose. And unfortunately, the only thing we're left with is the decomposition that I kind of showed you, which was, hey, let's try to isolate just the grades. Let's just isolate just the names. And then we can put together whatever things we need to return. That's the problem decomposition. All right, that burned more time. Yeah. Sorry? Sorry, about the last one, the one that I have? Okay, sure. Okay, if anybody wants to leave, you can't now because he asked a question. No, all right, go for it.
So basically, how did you use one list for both grades? How did you display them together?
Oh, one list for both grades. So I think you're talking about this one right here for the two different people. Take a look at where I defined the grades. I defined it on line number 4 inside the for loop when I was going through the original set of dictionary items. Okay, every time I go in for each student, for each course, it's course-based, then that grades resets back to an empty. And then what I do is I build it up, and that's for one course. Next course, it starts again from empty. You know, if I were to take this and move it up here, this is going to give me a lot of trouble, because what's going to happen is, okay, first of all, I'm going to have some issues with this, okay, but what would end up happening is this grade list would start as empty, but it would keep getting bigger and bigger and bigger for all of the different students. Probably not what we're looking for, okay? So that's why I was able to use one variable for both, because it's inside the loop. Okay, sorry, say that again. How do we?
The last result you got,
Yeah.
like how did you get this? I mean, can you please run the program?
Okay, you mean this one here?
Can you run the program?
Sure. Cannot pack. Oh, now what have I done to this whole thing? Oh, because I was modifying these things. I got to put all these back. There we go.
You see somehow like it says the course name is like grade, and the course name is grade.
Yeah.
This is how I do it.
Yeah, okay, so remember what I did is I isolated these items right here. We had the grade count and the average, so I printed those. So here we go, print, grade count, average, and, oh, sorry, there's one extra thing. I also printed the course code. And what I didn't have is I didn't have this line yet. Okay, I didn't have this line. So I isolated this piece of information because I knew in my dictionary I wanted to have the name of the course as the key, and I wanted to have these other items. Okay, so the way how you add something to a dictionary is you pick a dictionary. So I've got a dictionary called result, and what I could do is I go to a course code and I could say, give me just the average. All right, and what this would do is it would add just the average to a dictionary. So I've got a key, which is called course code. That's going to figure out which row to put it in, and this would end up tossing in an average. And of course, if I wanted to, I could send back a grade count instead, and this would give me a dictionary with just the grade counts. And if I wanted to display I want to have multiple things, well, I put it in as a tuple. And I got too many items in here. Okay, and I'll show you a couple of other things as well. So I put them into a tuples. Okay, that's how this was found. If the result was you wanted it to be a list, okay, put it as a list. If I was really doing this in a real application, I wouldn't leave it as a tuple or a list. I would probably do this. I'd be more inclined to do this. That way it's very clear what I've got in the return. Okay, so the process was go and find the information I'm looking for and then build up a data structure with it. And luckily it wasn't a heavily, deeply nested data structure. If it was, that would have been trickier to put together. And like that really complicated one we just got, that would take a little bit more work. All right, that's it. So I will see you on Saturday morning. So hopefully